Okay, let's say that we have a wire with this direction of current, and this wire will create a magnetic field around that wire, and on distance r we have magnetic field which points in this direction, and using the Biot-Savart law we can calculate magnetic field, and the magnetic field on distance r from this point is given by this formula. Now let's say now let's calculate the line integral around this wire. So let's do the following. Let's cut into small DL pieces like this, and let's calculate the line integral. So we have magnetic field times dl, and we can calculate this, and basically since the magnetic field and dl are in the same direction, so this line integral is quite simple, and it's equal to magnetic field times 2 pi r, right, which is quite simple. But now we can see that from formula here that actually this is equal to mu times current which goes through this wire. And Ampere first noticed and proved that actually we don't have to use this straight we don't have to use the circle, or we can use any kind of path on the around that wire and attach the surface on that path, and it will give the same result. And this can help us a lot of to calculate magnetic fields. This is not exact calculation, it's approximate, but it's quite handy, and yeah. So let's have some example. Let's say that we have some solenoid like this, and let's say that we have a current like this, and the magnetic field will point in this direction. And what is interesting more is here that magnetic field outside the solenoid, it will be pretty much equal to 0. So let's now try to calculate a magnetic field. So let's say we need to attach some surface and some path here like this, and let's choose direction around this path is like this, and we have here that the length is L, and this here is let's say small l. And now let's try to apply Ampere's law. So we have a line integral times dl, it's equal to mu 0 times the current which goes through this surface. And now let's see what we have here. So first, yeah, since outside the solenoid, so this the contribution of this part here, it will be 0. Also contribution this part. Okay, so some part here, so some part of this part will be inside, but actually this is the so the angle between this path and magnetic field, it's 90 degrees, so contribution here and here, it will be again 0. So only part of this path that will contribute to calculation, actually it's this one here. And this is the actually a line which is, so the angle between direction and magnetic field and this path is it's the same, and angle it's actually 0, and this will be equal to magnetic field time this line, right? And on this side we have what we have. So we definitely have this, but since the solenoid passes multiple times through this surface, actually it is we have n windings, but on that windings we have L, so this will be number of times which wire passes through this attached surface. Now we can simplify this a little bit. We can cancel this L and this L, and we have that magnetic field inside solenoid is equal to n times L times mu times I. And you can see this is a quite straightforward calculation. But now imagine that you have to use Biot-Savart law to calculate, so it will be probably nightmare.